All right, hello. Today we're going to have a discussion, and our broad topic will be acids and bases, but we're going to look at a couple of kind of subtopics within this, which are strength and concentration. And it's not uncommon for people to say something like, well, that's a strong acid, or it's not uncommon for people to say, well, that's a really concentrated. Well, here it is. Do you really understand what you're saying? Do you know what those two terms mean? Do they mean the same thing, or do they mean something different? Or are they even related at all? Let's find out, because I think you're going to be a little bit surprised. Let's start with the idea of strong. Most people are used to looking at big muscles when they say strong, or they're used to, thinking about how much can you throw or lift, or how much force can you exert. They're used to thinking about the opposite for weak. Oh, that you can't lift very much weight. Well, guess what? Those concepts don't have anything to do with strong or weak in chemistry in reference to aqueous solution. We just might as well get that out of our mind, because quite frankly, they don't relate. Okay? I think you're going to be surprised when you learn what strong and weak really means in chemistry. I don't think you probably really know. But I do think that you probably have a pretty good intuitive idea already of what concentration means. I think most people kind of already pretty well understand that. For instance, I have 3 flasks here. Each of these flasks have an equivalent volume of water. Remember, this is an aqueous solution. What did I do? Well, we put salt in it. Well, what is salt? It's sodium chloride. So the red dots are going to be sodium ions, and the blue dots are going to be chlorine ions. And why am I saying ions? Well, because I anticipate that sodium chloride will ionize or dissociate in water, okay? Creating an aqueous solution. And that's exactly what happens. Some of it is going, or a lot of it is going to ionize, okay? Now, when it ionizes or comes apart, then I think that leads to our, first point about concentration that I think you probably already understand. Because concentration does deal with numbers. So we look here and we just see a few. We look here and we see more. We look here and we see a whole bunch. So which one is the most concentrated? Well, you already know, it's this one. Which one is the least concentrated? It's this one. And I think that most people, yourselves included, already have a good, initial grasp of concentration. But here's what I don't think you know. So does that mean that's strong? Or does that mean that's weak? Or are those terms even related? I think we had better examine strong and weak by chemistry definition. So here we go. Strong and weak, I can kind of define them at the same time, because believe it or not, they depend upon the same thing. Strong and weak is all about how well whatever you put into water, typically we'll refer to that as a solute, but whatever you put into water, how well will it come apart? How well will it ionize or dissociate? Listen, if you put it in water and almost every single compound comes apart, then guess what? It's strong. So you mean strong isn't really numerical, it's more just conceptual on how well you can ionize? Yes. Well, what if you're weak? Well, if you're weak, then you only partially ionize or dissociate, or in other words, for partially would be slightly. Let's be more concrete. If you create aqueous hydrochloric acid, and almost everybody's heard of hydrochloric acid, you would take HCl, you would put it in water, and what happens? Well, it turns out that HCl in water, it just pretty much ionizes completely. So it means this comes apart. Well, you know what happens because you understand acids and bases. This creates an H plus proton that's going to be attracted to the lone pair of electrons on this oxygen, but it's going to be attracted to the water molecule. Well, that's going to make the hydronium, and you already know this. That's what makes it an acid. This is going to be this, so you're also going to create the negative chlorine ion. Okay, but here goes. Almost all of it comes apart. So because you get pretty much complete ionization or dissociation, that is the chemistry definition of strong. That is a strong acid. Now, I didn't say it was concentrated, so you better be listening today, because I didn't say anything about concentration at this point. I said this is the definition of a strong acid. Well, what would the definition of a weak acid be? Well, let's take acetic acid, which is found in vinegar. So CH3COOH. Now, you also recognize that this meets the definition of an areneous acid because it's bringing the hydrogen to the party with it, right? But when you put this in water, it ionizes or dissociates. So some of this hydrogen comes off. But guess what? Not a lot. Only a little bit. You get some partial ionization. Well, when that hydrogen pops off, it's attracted to the water just like before. You're going to create hydronium, so it's definitely acidic. And you're going to create this ion because it lost its hydrogen. But the fact is, you're not going to get that much, comparatively speaking, from here to here. You're going to get a lot more of this, and you're going to have a lot more ionization here than you are here, okay? And I guess honestly, let's not even worry about the amount of this, because that's not really the definition. The definition of an acid or base, strong or weak, is how well does it ionize. This one doesn't ionize very well, therefore this is a weak acid. This one ionizes really, really well, therefore it is a strong acid. And notice I have said nothing about numbers. Here is a visual that might help you understand a little bit better. So I've got acid HA. I don't know what the A is. I don't care. It's just a symbol. What is the H? Well, obviously it's my hydrogen, right? Well, if it is a strong acid, here's what happens. Every bit of it comes apart. So for every one of these A minuses that are created, you're creating a hydronium. So because they're equal, that is a strong acid. Okay? Now what about a weak acid? Well, let's just take the same thing, HA, but this time it's weak, so it only partially ionizes. So you still got a bunch of this that hasn't come apart. Now you have a little bit of this and you have a little bit of this, right? Because some of it did come apart, but you still have a lot that didn't ionize. So guess what? This is the definition of a weak acid. So far, what does weak and strong mean? Strong means you really come apart or ionize. Weak means only partially. All right, here's a list of some strong acids and bases. Once again, you can look at these on your own, but you'll see that they are areneous. Why? Because you can see where the hydrogens are coming from, and you can see where the OHs are coming from. Now, I thought you might get a chuckle out of this, but here's what I did. I included this picture because here's a strong base. Well, this is actually sodium hydroxide. Sodium hydroxide is actually a solid white pellet, but until you put it into water, and then you create an aqueous solution. Now, because NaOH ionizes so well, then you understand that what that means. That just means that because it comes apart so well, what do you create? Well, you create OH minus. All right? But listen, once again, we're not talking about numbers. We're talking about your ability to ionize. So because this can come apart so well, this becomes a strong base. Okay, well, what about a weak base? Well, this gives me a chance to get away from Arrhenius for a minute and go back to Bronsted-Lowry. Remember, Bronsted-Lowry was all about either accepting a proton or donating a proton, right? Okay, well, here you have ammonia. We put ammonia in water. Well, when we do, this is kind of cool. Ammonia literally has a relationship with water, and it's actually the water that gets ionized in this particular case. One of the H's from water is attracted to this lone pair. Okay, well, what does that create? It creates NH4+. Well, what else does it create? It creates OH minus. So because you have OH minus, it's definitely a base. I mean, don't lose sight of the fact that if you have this, if you have hydronium, you're an acid. If you have hydroxide, you're a base. Okay, but here goes. You have a lot more of this than you do this, because you're not going to get a lot of ionization of water. You're going to get some water molecules will give up their H that will be attracted over here, but not, comparatively speaking. If you're looking at this idea and you want to know whether it's strong or weak, this is weak. Why? Because while some of it will, a lot of it isn't going to. All right, so this is just a total example because not a lot of it ionizes. So guess what? It's weak. So what have you learned? You've learned it doesn't have anything to do with how much weight you can bench press. It has everything to do with how well you come apart in water. If you come apart well in water and you produce hydronium, then you're going to be considered a strong acid. If you don't come apart very well and you only produce a little bit of hydronium, then you're going to be a weak acid. If you come apart really well in water, almost all of you, and you produce hydroxide, you're going to be a strong base. If you don't come apart very well, or if you don't influence something else to come apart very well, then you're going to be a weak base. I haven't said anything about numbers. Numbers goes with the idea of concentration. Strong or weak is all about how well you ionize. I hope you learned something there. Okay? So let's talk about concentration, and then let's decide whether or not how they're related. All right, so let's talk about concentration. So intuitively, once again, you already know that here, I've got this, whatever it is that I've got in my aqueous solution, so you look at it and you say, wow, I see a bunch of it here, but I don't see as much of it here. Well, whatever this is, you see a bunch of it here, you don't see as much of it here, well, then that's more concentrated. Yes, because now we are tying ourselves to amounts. So the amount of ionized solute here, in this equivalent amount of water, you got a lot more. So because you have a lot more, it's more concentrated. You got less here, so it's more dilute. That's the two terms here. This is more dilute than this. Now, I'm going to tell you something, though. This isn't telling you anything about strong or weak. Let's make sure you understand, I'm not saying anything about strong or weak. And so if you're sitting there now and you're kind of scratching your head, then maybe we better discuss something. Okay? Could this be dilute but still be a strong acid? Now think about this. Could this be concentrated and a strong acid? Could this be dilute and still be a strong acid? Because remember, strong and weak are just how well you come apart. Concentrated is like how much of something you have. Well, okay, if you understand what I'm about to say, I think I'm going to be able to really help you here. Think about the human stomach. Okay, well, the human stomach can really produce a strong acid. It produces, if I'm not mistaken, it produces hydrochloric acid. Well, what do we know about hydrochloric acid? We've already established it. That's a strong acid. In fact, the pH of the stomach after you eat certain meals can drop down to like 1 or 2. It can get really acidic in the stomach. But does it make any sense from a health perspective? Come on. Does it make any sense from a health perspective for your stomach to be that acidic when it's empty? And you're like, no, that doesn't make any sense. No, it doesn't make any sense. So when you're empty, it may go up, the pH may go up to 4 or 5. It's still a strong acid. It's just more dilute. It's not as concentrated. Okay? You don't have as many, you don't have as much of it per unit volume. So think about this. Strong and weak are almost in a way sort of independent from concentration. Strong and weak depend upon how well you ionize. You can be a dilute strong acid, but you could also be a concentrated strong acid. When that pH drops down to 1 or 2, don't you figure that not only, are you, dropping the pH, but, what are you probably doing there? Well, you're probably becoming much more concentrated at the same time. Yes? So think about that. Think about the fact that strength and weakness, okay, are related maybe to concentration, but concentration is more about how much. All right, so let's concentrate on concentration. So there's really two ways that we kind of tend to talk. I say two ways. Let me back up. There's more than two ways. We're just going to look at a couple of ways that we might look at concentration, and in this class or in chemistry class. All right, so we might look, and sometimes you see this. You see this like this one. If you can read it, it says 0.9% sodium chloride irrigation. Well, what does that 0.9? What does that mean? That's a way of talking about the concentration of sodium chloride in this solution, okay? Well, in this case, they're talking about the mass of the solute in grams over the volume of the solution in liters, and then to get that percentage, they just multiply it by 100. So really, they end up with grams per liters, and so that's kind of a way that you can look at the concentration. There's more than one way to look at concentration. This might be one way that might apply sometimes when you see sort of this percentage that's being used. Okay, so you're basically just using this formula, and you can always pause and stop and take a look at it. Okay. All right, what's a second way? A second way that we're going to kind of dwell on a little bit here in a minute. Well, you might look at moles per given volume. So you might look at like moles per liter. So if you had a 3 molar solution of sucrose, which is sugar, if you had a 3 molar solution, that really means that you would basically have 3 moles per liter. It's not uncommon for us to use solutions in class or in chemistry where it might be like a 0.5 molar whatever, or whatever is called for. And so that is a way, so get it in your mind right now. When you see that 0.5 molar whatever, that's simply a way of talking about the concentration in moles per liter. Now, you might not have a liter. I understand that, okay? All right, let's continue. Concentration can be affected. It can be affected by like temperature, pressure, volume, amount of solute versus solution, or the solubility of the solute. So I do want you to understand that concentration does have, variables that can affect it. All right? All right. Question. Can you be strong and concentrated? Yes. Now think about this. So you take something like a very, very strong sulfuric acid. Well, why would sulfuric acid be strong? Well, if it's strong, then it ionizes easily. So you're like, I understand that. But how is it concentrated then? Well, if I have several moles, right, per volume, then I'm concentrated. So in the one case, I'm talking about how well you come apart, and the other part, I'm talking about how much of you I have per volume. So can you be strong and concentrated? Sure. Can you be strong and dilute? Sure. Okay. Can I dilute a strong acid? Yes, and I bet you already intuitively know how you would do it. How would you do it? You'd add water to it. Right? You would increase the amount of water versus, right, your solute. Well, what would you do? You would lower the concentration. Remember, concentration is about numbers. Strong and weak is about how well you come apart. You could have a weak acid that has a high concentration of this. In other words, you got a bunch of this in here, but it's still a weak acid because this doesn't come apart very well. So you need to think about this. Yes, you can have a high concentration of something and still be a weak acid or base. All right, reminder. Concentration is the molarity or molar concentration of a solution, okay? And it is defined as the number of moles of solute per liter of solution. So we define molarity, all right, or molar concentration as the number of moles of solute per liter of solution. So we're going to learn in my next presentation, we're going to learn how to do something practical, which is how do you mix up a solution to get a certain concentration. Now, could you use a weak acid to do that? Yeah, you could use a weak acid and mix it up to get a certain whatever. Could you use a strong acid? Yes. Could you use a weak base? Yes. Could you use a strong base? Yes. So in closing, strong and weak are all about how well you come apart, but concentration for us is going to be all about how many moles of you do I have in a given volume. And if I can make that number go up per unit volume, you're going to become more concentrated. If I make that number go down per unit volume, you're going to become less concentrated. Strength, strong, weak, concentration.